So welcome to our third Intro to Game Development workshop. This is on the single most important piece of software you'll probably ever learn to use. Definitely the most important piece of software in game development or software development. That is a beautiful thing called Git. If you have no idea what Git is, don't worry. We will teach you all about it and try to make you Git competent by the end of the next 2 hours. Yeah, any questions about what we're going to do? Should be pretty straightforward. Cool. So what is this Git thing? So Git is what we call a version control piece of software. The easiest way to think of what version control is you can think of version control as being like Google Drive, but for software. And because it's special built for software, it has a lot of really awesome features that a basic Google Drive or Dropbox or Box or OneDrive or choose your favorite competitor wouldn't have. One of the big ones that's really important is it lets you wait until you've finished working on something before it synchronizes that change to the public copy, right? So you don't have to deal with other people's bugs. Right? You don't get their code until they've debugged their code. Right? You're only dealing with your bugs. That's really nice. It allows you to keep track of old versions and roll back them as you want to. Right? So if you realized you broke something or you want to look at how you used to do something, it's storing all of that for you. And you can always go back as far as you want to or look back as far as you want to. And when you roll back, it keeps all the stuff you did after. It doesn't delete your future progress. It's got really awesome control of just like going anywhere through your history as you see fit. And it allows you to manage multiple parallel versions. So if you want to like take the same piece of software and go 2 different directions with it, right? You can fork it. You can make 2 different versions of the same software, build on them in parallel, and then later down the road when you decide, hey, I actually like bits and pieces of both of these versions, it allows you to sandwich them together and mix and match and bash them together. So it's really awesome. It's really, really powerful. It's basically how we keep track of all software everywhere in the entire industry. If it's not using Git, it's using something like SVN, which is basically Git but older. Any questions about what is Git? And what you're going to do with Git, and what its purpose is, and why you should never use Google Drive for a game project. Please don't use Google Drive for your game project. I'm speaking from personal experience. Nothing will kill your team faster.
Me too. Don't do it.
Use Git.
Use Git.
You want these features. They're really important, especially that first one. Also the fact that because of how Git works, you don't actually have to constantly upload and download everything. So it works really, really fast. So you can like get changes on giant game projects in a couple seconds, which is fantastic. Okay. So what are some of the key concepts we're going to be dealing with when we're talking about Git, right? What are the players? What are the chess pieces? So the first thing that we're going to talk about a lot is the idea of a repository or a repo in the lingo. Right? And all a repo is, it's a set of files that we're keeping track of together, right? So like usually one piece of software or one game has a repo that goes with it. You can also kind of think of each repo as being a folder, because on a certain sense they literally are folders, right, of just files that is being tracked as part of Git, right? And then we have special types of repos called remotes, or remote repositories. And so what makes a remote special is that most repos are being held on your local computer. Right? Your local copy is a repo in and of itself. But you also have another remote repository, which is being hosted on a public server somewhere or a private server somewhere, that is keeping track of the central grandmaster copy that your entire team is talking to, right? So remotes are very important. That's how we actually do sharing, is it all goes via a remote repository. Any questions about repos or remotes? What the difference is? Who can explain to me the difference between a normal repo and a remote repository?
So a remote repository is held on a separate server. The regular repo is held on your PC or whatever device you're working on.
Yes, that is very correct. And then we talk a lot about changes in Git. Basically, a change is what you think it is. Any line you add to a file, any file you add, any file you delete, anything you delete out of a file, or any line you change in a file. I believe those are the 5 types of changes that Git pays attention to. You don't need to know what the list is, but basically anything you add, anything you remove, or anything you change, each atomic unit of that is a change. And then we're talking really about changes en masse, right, and what we're doing with these changes. Because Git is very oriented around changes. And then what's really important is the idea of a commit. And a commit is basically when you take a bunch of changes that you've done, right? Like, you know, all the changes that come together to program a new feature. And you stick them together into a big unit called a commit. Right? And that's just a big block of change. And those are very, very important. We talk a lot about commits, right? Which are just atomic collections of changes. Another important idea that we talk about is we have this branches and branching. This is where I mentioned earlier that you can have 2 parallel versions of the same software going, each with different changes and different stuff going on in them. That's branches. That's where branching comes in. Though even if you don't do that and you're just having one version, it's important to be able to think of it as a branch. Because even then, technically speaking, every copy of the repository on every person's computer has its own technically separate branch, even if they're all identical branches. And what basically a branch is made up of is a bunch of commits, right? So every branch is a chain of commits, and if you want to make branches branch off of each other, you just put certain commits on one branch and you put certain commits on the different branch, and that's where the difference comes in, is what commits each branch has. Does that make any sense? I feel like that's kind of a big, weird concept. Any questions? Do you want me to circle back, or do you want to just kind of pick up on what I'm talking about as we go along and you see some more examples? Okay, we're going to do that. And then the last thing you kind of need to understand is this idea of your working directory, which is the actual folder you're going to have on your computer that has a copy of all the files out of the repo and that you can change and that you can work on. And that's really how you edit the repository, is by editing your working directory. And as the working directory branches away, branches is a bad word, spheres away from what you have committed and the commits it has, building it up, those are changes, and then you take those changes and they get put into commits, and then they become actual cemented parts of the repository. And all of a sudden your working directory isn't all weird and changed and offbeat from the repository. It is part of the repository. Right? Basically, yeah, that's just your live copy that you edit. And the changes you make to the working directory become those changes, and then the changes get committed, and those commits get put on branches. Any questions, comments, concerns, clarifications, misgivings about any of this weirdness? Okay, I think the easiest way, you'll just pick up on this as we go along. I don't think it's worth dwelling here, especially because we're already low on time. Okay, this is kind of an important thing. These are 2 things that get confused a lot that it's really important to be able to differentiate: Git and GitHub. Git is a piece of free as in free beer, free as in freedom, open source, version control software. Right? It is just this little packet of what's a repo, how do I commit, what's a change. It's free, it's floating out on the internet. It's not really tied to anything, it's not even owned by a company. GitHub, on the flip side, is a company, a for-profit company, that provides servers that host remote repositories, right? GitHub did not make Git. They have no right to Git. They just run the Git they just sell you servers that run Git for you and host remote repositories, which is a very, very useful service because hosting a repository on your own is annoying. I know, I do it. And they do it well, so that's nice. But they're not technically Git, right? They have no attachment with like the repository on your computer, right? That is run by Git proper, not GitHub. And there are other competitors to GitHub, other services that will sell you servers that host your repositories. Most of them are pretty good. Bitbucket's a big one. GitLab is a big one. But GitHub is kind of the go-to that everyone knows and everyone likes. Just got bought by Microsoft for, what, like $7.5 billion?
Something like that.
Right.
Yes. Any questions about the difference between Git and GitHub? Who made Git Bash?
Yeah.
Git. That's actually why I have you guys use Git Bash, because Git Bash is the Git client made by Git themselves. I think that's the next slide, actually. Yeah, Git Clients. So Git is this kind of tiny little piece of software that does nothing but track changes. And because it's free and open source and all that jazz, not only are there companies and other people who will host your remotes for you, but other people have come along and made Git clients that make interacting with your own local repositories a hell of a lot easier. Because Git Bash is great, but Git Bash is also Bash-based. So if you aren't like me and don't live, die, and breathe by Bash, or don't know what Bash is, it's probably not going to be your favorite way to interact with Git. So there are lots of great options out there. Tortoise Git's a really popular one that's cool. It integrates right into your file explorer. SourceTree is a popular one that I think is the officially endorsed one by this club. GitHub makes one that's not very good. Don't use GitHubs. Theirs is called GitHub Desktop if you are curious. But yes, so just like you get to choose where your remote repository is, you get to choose what client is actually allowing you to control your local repository. Yeah, those are clients. Clients are intercompatible, right? Like I can, push from my SourceTree repository to GitHub, which then you can pull down on Git Bash, and then you can push from your copy of Git Bash to another repo on Bitbucket, and someone else can pull that with Tortoise Git, and all the software works together because Git is the glue that holds it all together, and Git is compatible with Git, period. So it's just, different people building on top of it and adding different little bells and whistles. But it all runs on the same blood. Okay. So let's actually do some stuff with Git. All right? Enough theory, enough basics. Let's get our hands dirty. So this is all the stuff that we should have done already. The last step is everyone is going to need to open up Git Bash. You should have a window that looks like this. For those of you who know what a bash terminal is and or like Linux, this will be a very familiar thing. This is just a bash terminal. For those of you who don't know what bash terminal is, this is probably terrifying. Don't worry, you don't need to know it that well. And then the first thing we're going to need to do here is we're just going to need to tell it what directory or what folder. Computer people speak directory equals folder. Just get used to that word. You're going to hear it a lot if you're in computer science and or hang out with computer scientists. So we need to tell it what directory we want to be in. And we're just going to work in our desktop or whatever other folder you want. But I'm going to work on my desktop. And the way you change that so that you're working in your desktop is you just do cd space / desktop. And now you'll see it's telling us that we are in our desktop. And now we are ready to go. Wave your hands and yell and scream if you're not ready to move on.
I can't find the freaking squiggly thing.
Right there. Shift that button.
Yeah.
Okay. So yeah. Okay. So now we actually need to. We have a remote repo that you've all joined. Now we actually need to get a local repo going on our computer that's going to talk to that remote repo. And the way we're going to do this is by doing something called cloning, right? Cloning is basically how you take a remote repository and you make a local copy of it. So the way you're going to do that is you're just going to go to GitHub. You should be able to get to this page pretty easily off of your invite. Or you can go to this URL, and if you're logged in, it'll look like this. And then you just kind of want this URL. You can also just use this URL off of my screen and not copy it if you feel like copying it down off the screen. That will work too. Go ahead and copy it. And then go over to git bash. And then do git clone Control-V. Right! Bash on Windows is dumb and it doesn't support copy-paste.
Wow.
Yeah.
You can right click and
Yeah, if you right click and paste.
Oh, what?
Yeah.
That's dumb.
No, like literally just right click will like paste
Yeah,
on
just
it.
right clicking. Not a copy
Copy
coming
and
wrong.
No, that's not the thing. Okay. There we go. Damn it, Windows. This is why I stopped using you. And then we can go ahead and press enter, and it will tell us a bunch of stuff is going on, and then be done. Has anyone not cloned? Yes. Hmm?
Weapon destruction. Fatal. It says fatal, you must specify a repository.
Did you put in the URL like this?
Yeah, that was pulled from the bar, right?
You need the .git at the end. That's the big difference. Yeah.
Git clone, right click.
And then, for those of you that are done, you'll notice that this has made a new folder on your computer. And the way we're going to gut into that folder is we're just going to do cd./training. And then I misspelled dummy. It's only one M. Training dummy. And you'll see that it has now pulled us into training dummy. So go ahead and cd into training dummy with this command right here.
So what does the squiggly line mean? What is it?
Squiggly is shorthand for your personal directory. So like your user directory, right? So you know how you have like on my computer, like there's a folder named Ryan, and then inside that there is my desktop, my documents, my stuff, right? If I want to just talk about that directory Ryan, I can just write squiggly and that stands in for it. And then squiggly / whatever is like Ryan, and then inside Ryan look for the next folder. So squiggly / desktop, Ryan's desktop, the desktop folder inside of Ryan.
Okay, and what about the period?
Period is this folder, whatever folder I'm in right now. So I could also, could have done cd squiggly / desktop / training dummy, would have done the same thing because I was in squiggly / desktop. But also that's just bash stuff. We're not actually here to learn about bash, even though bash is great, and please let me teach you about bash sometime. Anyone yell and scream if you're not inside of your Git repo yet?
Didn't make a folder for me.
It's not even the files didn't even clone either. It just didn't do anything.
What?
Like went through everything, but there's no file for it. Like no folder. Unless I'm blind.
Have you done
It's not a new
LS?
folder.
LS?
You have to right click on the desktop and click refresh to get Windows to rebuild it. Try navigating to desktop with the file explorer.
Okay. So while they're fixing that problem, we're going to talk about the basic Git cycle. These are the 4 most important commands that you will ever use in Git. You will use them ad infinitum. You will memorize them well. So the first command that you're going to use over and over and over again is git add dot. And git add dot just says, hey, all those changes I've made to my working directory, yeah, I want to keep those changes, right? It does something called staging to them. It stages them to be committed. You don't really need to know about that or understand what that is. Basically, you just need to know that git add dot tells Git that all the changes you made to your working directory you actually want to keep. And the next command is once you've done git add dot and you actually are like ready to commit those changes for good, is you need to do git commit. And when you do git commit, you want to do git commit -m, and then inside of quotes you're going to put a little message. Don't worry about that too much. There's a whole slide coming up on it. But know that you're gonna. It's a little bit longer than just git commit. It's git commit -m, and then write some shit. Once you've committed, you're gonna want to get all the other commits that people have made, right? All the other changes your collaborators have made on the remote. The way you get those is you do git pull, right? And git pull takes all the commits that are on the remote repository that aren't on your repository and grabs them and adds them to your repository. And then git push kind of does the opposite of git pull, and it takes all the commits that are on your repository that aren't on the remote repository and adds them to the remote repository. And now, because you got all the stuff that you didn't have that they had, and they got all the stuff that you had that they didn't have, now all of a sudden you have synchronized after this 4-step process with the remote repository, and you are keeping up to date with all your team on all the changes that are going on to your game.
It looks like you're using the
Yes.
So, for example, if someone push a file into the remote,
Yes.
and you push your version on there, do it like do your version like override theirs?
It works on a change by change basis.
So it's not a file by file; it's a line by line.
It's line by line. Right? So if I add a few lines to a file, and then someone else adds a few lines to the file, and we both push, and we push it in the right way so that we don't cause a merge conflict, which I'll talk about later, now all of those lines will be in the one file together.
In the order that they were pushed.
Now try.
In the order that they were typed. So it'll keep track of line numbers and put everything at its appropriate line number. If you both try to add 2 lines to the end of a file, for example, or to the same line number, that's a merge conflict. And we'll talk about this later.
So
Yes.
if someone like remove a line from a file in the remote, and then you upload your file there, but your file still have that line, does it?
Well, but this is... The thing I think you're missing is that there's a really, really ingenious little reason to why you always pull before you push. And this is because that makes that case impossible. If they made a push, if they pushed a commit that deletes a line from a file, right, and then you do something else to that line, right, you have to pull that change. So that line is going to get deleted from your working directory before you get to push. Does that make sense? Yeah. And then, of course, there are a whole bunch of cases where 2 changes can immediately contradict each other, and that's a Git conflict or a merge conflict, and we'll talk about those. They're a big deal in Git. So your mind is definitely going to the right place. Yes?
Do you have to add dot to the stage before you push, or?
To where? Oh, git add dot? if you don't git add dot, nothing will get committed.
Oh, okay.
It only commits what you've git added. Git add dot specifically is git add everything, right? So if you don't do this, you're just going to make an empty commit that has nothing in it.
But if you were to make an empty commit, would that break anything, or would that just be?
God, I don't think I've ever made an empty commit. Greg, do you know how Git handles empty commits?
Empty commits.
Does it just yell at you and say that don't do that? That's
yeah,
dumb.
Just like, well, that's not going to do anything, and then error
I don't know.
message.
I've actually never tried to make an empty commit. I can try that right now.
Yeah. Okay. So let's actually practice this cycle. So what I'm going to do is I'm going to, I need to do this thing. I'm going to go to my desktop. Where is training dummy? Here's training dummy. I'm going to go into training dummy. I'm going to make a new file. I'm going to call it hello.
It'll say
Sure.
Nothing to commit.
What?
Working tree clean. Nothing to commit.
That's what it'll do. And I'm going to put some text in here. Like, Git is fun. And I'm going to save it. I'm going to close it. And then if I go back over to Git, what's the first command I'm going to type? Git add dot. And then what's the next thing I need to do? Git commit. -m adds a thing. And then we're gonna go Git, what's next?
Push it?
No. What do you always have to do before you can push?
Pull
Pull.
first.
Git, pull. And then now we're gonna go Git, push.
So this is a string that you would do no matter what. You would always do these 4 or 5 steps?
4.
4 steps.
Correct. And now it's asking me for my GitHub username, so I'm just going to go ahead and log into GitHub here, because it wants to make sure that you actually have rights to change this remote repository, so that not just anyone can wander in and mess with your code. And then it's going to prompt me for my password, which I will put in. And then it's going to go ahead and push. And it's going to tell me that it successfully pushed, that this commit went from my master to their master. Yes.
If I move the training dummy folder into another location in my computer, will that still work?
It will still work. It doesn't care. It doesn't care what's around the training dummy. It's only looking inside of training dummy. Right? Everything is stored within that folder. Just make sure you drag the entire folder and not like all the files in it, because then you're gonna screw things up. You have to move the folder
And,
as a block.
And can we commit like single files, or do we have to commit everything at once?
You can commit single files. You just, if you only want to commit certain things, you need to get fancy with your git add, right? So if you only want to commit like the changes to one particular file, it's git add that file, as opposed to just git add dot. Git add dot specifies everything. Yes.
The $sign changed to an arrow. I don't know what I hit.
Oh, that would mean that you forgot your close.
Yeah.
Your
How do I get
your
it
close
back?
quotes. Put a quote and then press enter.
Cool.
Okay. So everyone who hasn't done so already, go ahead, add a file, and get through the commit push pull cycle. And push some stuff, push some random files up to the up to our repository. I think that's okay. Yeah. And while you guys are doing that, I'm just going to talk for a hot second. You don't need to pay attention. You can just keep writing about those little messages that come after commits. Those are called commit messages. they're very important. Basically, that's you telling the rest of your team, hey, what this commit is, what's going on here, what changes you put in this commit.
Can you go back to the list?
Oh, yes, I can. Right, so you want to write good messages here, right? You want to keep them short, right? People don't like reading long commit messages. They want to just look at it and glance at it and understand what's going on. Generally speaking, you want to keep it down to like, 5s of words. You want to keep it very informative and very technical. Some good ones are like, fixed this bug, and then you say what bug you fixed, right? Like fixed spawn bug, or added shooting, or tweaked numbers, or added AI to goblins, right? Those kinds of like really short, informative messages make really good Git messages. People like to make joking Git messages. They're funny. The problem with that is everyone can read your Git messages because your Git is being held on a public server that everyone can go look at. That includes your Git messages, your commit messages. Your employers will read your commit messages. Try to not swear in them too much. Don't be like your president. Don't make every single commit message just like.
Or just like screaming, like actually.
Don't just make every commit message caps lock the F word. Even though I know you really, really want to, it's so satisfying because that's how it feels inside. But
Repo sites like to put up like the first, I think, 60-ish characters as like the first line to be like the main message that you'll see. So that's like a good like length for like a title, and then skips a few paragraphs down, and then start adding details if you want.
If you use the Visual Studio Code Git client, it actually won't let you use commits longer than 75 characters.
Oh, neat. Okay.
It will not. The client refuses to push for you if you've made too long a Git. And it starts turning yellow as you get close to the 75 cap.
Oh, wow. That's cool.
It's nice. I really like the Visual Studio Git client. Yes?
While doing my Git poll, I got this. It's not really an error message, but it's just a message. I'm wondering what to do.
What does... No, yeah.
Please enter a message. Yes, so you have to supply a commit.
You guys should also, as you guys are polling, you guys should start seeing other people's files showing up in your Git repo as they have committed changes and you are now pulling those changes. Yes.
I don't know what just happened. The poll.
This is.
You can start that.
Just do Z. Just type in ZZ. Capital Z, capital Z.
I got a same thing.
That's so you know how. That's a merge message, which is basically the same thing as a commit message, except for.
You're gonna need to explain this to the room because I'm seeing it on the screen.
Okay, so for those of you, this is for those of you who just got prompted with weird blocks of blue text and scary squigglies and a sudden lack of control. Let me explain what just happened to you. So basically sometimes when you pull, if you and someone else were working in parallel, right? So you made two different you can't explain. Okay, right? So if me and my teammate were both here, right? We were both at this commit. These dots are commits, right? And I went ahead and I made this commit. And then I made this commit, my teammate made this commit. And then all of a sudden I pulled over my teammate's commit. Does this structure make sense to everyone? Right? This right here, where I pull this commit over here, is called a merge. We'll talk more about them detailed later. But basically, most of the time when you're pulling, you're going to wind up doing a merge. Every time you do a merge, just like every time you do a commit, you need to write a little message explaining what the merge is. Unluckily, because you don't know a merge is about to happen, you don't get a nice chance to write your message in advance. So it's going to yell at you in bright blue text, hey, write a freaking commit, writing freaking merge message. by default, unless you've changed it, it's going to try to have you write that merge message in something called Vim. Vim is amazing. Please learn Vim. Vim is also terrifying. I will not teach you. I don't have time to teach you how to use Vim or even write an A in Vim. So
How do you quit Vim?
So just whenever that happens, just quit out of Vim with a by typing 2 capital Z's, and be happy with that. Yes.
So my quit solution was Alt F4, and now I'm trying to get back. What was the command to get back into the training dummy directory? Training dummy.
CD, and then you need to type the path of the directory.
You want to know what's in this directory? You can check ls and enter, just to see what folders are there.
You probably want to do cd squiggly / desktop / training doomy.
Okay, so yeah, you can go to the folder with CD.
All right. Any questions? Has everyone successfully gone through this cycle?
Almost.
Almost.
I'm not sure.
Well,
I'd like to log in. I messed up. I don't know.
So there's actually multiple ways to get out of it.
oh, it just it just said, hey, you couldn't actually push because you logged in wrong. So you just need to push again and type in your credentials correctly.
Capital Z?
It's capital Z, capital Z.
Okay. I shoot :Q.
: Q also works.
Is that save it? Is that right?
: Q does not save it.
:Q exclamation point? Is that what it is?
: Q exclamation point is a hard quit.
Okay, cool.
So that does even less than : Q.
Neat.
Yeah, I think I did sign in. I wanted to make sure. Just does this automatically.
Yeah. So ZZ is save and quit. : Q is quit and don't save.
Okay.
And then : Q bang is get me the fuck out of here. I don't care what gets broken in the process.
Okay, cool.
Are these last name Osama?
It will be, yes. It's still not working? Are you making sure you don't have cap locks? You're typing in your... You using the same account that got added to the repository?
Yep.
That's weird. Try one more time. Make sure you're typing it perfectly. Oh, it's not even letting you type it in. What?
Where's the right hello? The one that you have.
Yeah? What about it?
Like, it's not in here. I remember on yours, one of the uppercase H. I see other people's things. Did you open something?
I did.
Did that have to push?
I should have pushed it. Let me pull and see what's going on. It's also entirely possible someone could have deleted it. Yeah, it got deleted off of my computer too. So someone must have pushed commit but deleted that. Because deletions are also changes. Let's see if we see it in the changelog up here. I do not. Interesting. Huh. Okay.
So after I put push, like the green text, like that.
So you have?
Yeah.
Okay. And then.
Because I didn't see my thing.
Actually, you know what? You try this. Try running these 2 commands. Also, for those of you who are done with your cycle and you've pushed and pulled all this stuff, go ahead and run these 2 commands. Except, put in your username and your password. By default, it will just always prompt you for your username and password. But if you don't feel like typing them in ad infinitum and just want Git to remember them for you, these 2 commands will tell Git, hey, remember this username and password ad infinitum. Yeah.
I got a rejected error.
Will it actually remember your literal password, or will it secure it?
It doesn't remember your literal password. I don't actually remember what it does to it though. It will remember your literal username
My
and
thing
literal
did
everything
not
else.
get pushed. Because after I hit push, like I tried to fix it. What?
Oh, it's still pushing.
I'm opening a text file.
Oh, maybe that would
That's
work.
because
That's weird.
pushed ahead of you.
Control D.
Now you're gonna do the merge.
And this is easy.
Yes. It should not take this long.
Text file to any server.
Yeah, no, Git's supposed to be really fast.
Aha, there's a thing.
Here.
Yay.
And then
Oh, wait.
those of you who are done and you've logged in and stuff, I guess just make other changes and have fun messing with other people's files and committing and pushing and pulling it. Yes.
When I'm doing the git config, do I need to put the rotation up?
Yes, yes you do.
Or you do that right after?
Everything in yellow you need, everything in orange is a stand-in for something
Tell me
else.
to do anything with pushing.
And of course you don't need to type a new $sign.
To
But,
read
yeah.
Oh, right.
You still, the $sign still has to be there. It's just-
Yay, it appeared.
On that.
Yay! Okay.
So somebody really wants to read the DOD script. How they get it?
All right.
Did I?
So yeah, those of you, I'm gonna give it a. Who is done with this and has done a complete commit, push, add, commit, pull, push cycle. And who's gonna be done with that in like the next 30 seconds? And who needs more than 30 seconds to get up to this point? You're still having, it still didn't work?
Yeah, I just didn't do it.
Yeah, I was gonna rename the file that I
Just like
Okay. So did you rename the file already?
Yeah.
Okay. So you want to git commit message.
Your password is.
Did you?
You're using.
You have to
Oh,
add.
for
just
email,
ignore this stuff
you
because
don't
I
want to.
was,
You don't want to set it to
Even
your.
if I-
You don't want to set it to your
Yeah,
user
so it doesn't
name.
know the file.
You
is
want to set it to
effectively
your email.
To the repository.
Yeah, it's weird.
It'd be add space dot.
Wait, so we're setting the user name to our email?
Now commit.
For username, GitHub wants your email to be in here.
Oh,
What email?
Should there
For
be a
username?
space between?
Your whatever email GitHub knows about you is what GitHub is going to want you to
Matter.
in here. Hit password has to be your GitHub password.
Does it matter if there's a space? Yeah, there needs to be a space.
The second step, git
And then say
Git.
renamed file.
Commit.
commit. Thank you.
Okay.
You are committing to making these changes.
You can commit that.
Sorry, remember that. Git comp commit dash n space dash n.
Yep.
Should do anything
Cool.
after that?
Yeah. And make sure to put in the
What do you
messaging
do
parts. Huh?
You don't.
And now try
merge conflicts.
pushing. Yeah.
Pulling all the.
What do you mean? Yep. Because at any point in time,
Does
we're
it-
doing
does it
the
match
last
my
call
password?
for this one
Oh.
save the default with the
Try
chat base,
try
so
running the password.
Hold
again.
shift, pressing twice.
Same. No.
Okay. Now you have everyone else's changes brought in. You can now push.
Anything going well?
Yeah. So the point of setting the username and password
It's so that you don't have to type it in every single time.
time we have to push one push, right?
Yeah. You can just not do these two steps and then just, every time you want to push, type in your username and password.
If it keeps
That
yelling
works
at you, that
perfectly
means
well.
Yeah,
That's just
yeah.
annoying.
And how often would we have to set our username and password? Have to be like
It'll save it ad infinitum. So you just need to run these two commands again if your username or password changes.
Okay.
Sure, you could try.
And push.
I didn't even remember what these were because I ran them on my computer when I got my computer and I haven't touched them since. So I had to go look them up. These are two that you will not memorize. Unless you're just a Git master and memorize all the Git commands.
So this is pretty important for industry, I'm assuming. Knowing all this.
Oh yeah.
How long would you say it takes to
You're
learn
good to go
this
now.
software to like intermediate level?
I'd say I was pretty comfortable with that after about using it pretty consistently for 6 months. And then you get better with time.
Yeah. And is it like unlimited knowledge of that kind of software, or is it like?
I mean, Git only has like 15 commands.
Okay, so.
But some of them get pretty shenanigans. You can do some pretty crazy shenanigans with those 15 commands if you're smart.
You have to have a ton of arguments.
Yeah.
Some extra things. I found out commit does have an argument to supply an empty commit as long as you put a message in.
Huh.
It says that that is turned off by default because typically an empty commit is considered an error.
Yeah. Yes.
Yeah, it's but the username password stuff was right.
That's freaking weird.
What's going on? Is that probably
Yeah.
the thing where everyone's pushing stuff quickly?
Do you mind if I move on?
you can- yeah, you can move on.
Okay. So the next thing we're gonna do. Oh, you've already done this. Do you guys want to push and pull more files, or you just want to keep plowing ahead? Keep going? Cool. Okay. So I've mentioned these big scary things called merge conflicts. Sadly, the guy who brought them up had to leave. But let's actually talk about these things, because these things are the bane of Git. These are your new worst enemy. So what is a merge conflict? The short of what a merge conflict is, right? I've explained to a short of it is when I have made a commit on my computer that does something to a certain line of code, right? Like in file movement line 47, it changes it to 4, right? To the number 4, and then I pull a commit that changes that exact same line to the number 7. Git wants to give the user as much control as possible, right? Git wants to make exactly what you want. So Git's not going to guess what you want. At the same time, Git doesn't know if you want a 4 or a 7 there, right? So it's just going to panic. And it's going to do something called a merge conflict, where basically it's going to say, hey, you have 2 conflicting versions of the same line. You've made 2 conflicting changes to the same line, right? They're asynchronous, so I don't know which one gets precedence, right? It's not like one change was happened and the other change happened, right? They kind of happened in parallel, so it doesn't know which one gets precedence. What do you want me to do? And it really won't let you do anything until you tell it what to do, right? Is basically what's going on in a merge conflict. Generally speaking, the correct answer to merge conflict is be smart and don't get merge conflicts, right? The golden rule is that only one person gets to work on a file at the same time, right? And then they need to push all their changes on that file, and everyone else needs to pull all those changes before anyone else can work on that file. But merge conflicts happen to the best of us, so let's learn how to actually deal with them. And the first thing we're going to need to do, if we want to learn how to deal with merge conflicts, is let's make some. Let's be dumb for 5 minutes and light Git on fire. So everyone choose a partner, and with your partner, choose some line in some file somewhere on our shared repo. I made a file called merge conflicts please that you can choose lines of, or you can choose other lines of another file. There are plenty to choose from. None of them are important. And just both agree to make different changes to that same line, and then go through an add commit pull push cycle, and see what happens when you try to pull your friend's commit that changes that one line that you just changed. And it should yell at you. Hello, David. You can also, yeah.
Sure. Let's just,
This is a Git tutorial.
Yeah, we just
We're manufacturing Git conflicts on my testing dummy.
Yeah.
We're lighting it on fire so we can fix it.
Oh.
That's actually like a really good way to go about it. 'Cause that's when it gets worrisome. I'm not here to make the game start. Create project.
Push without
Yeah, this is the only workshop today. And we have 2 on Tuesdays and like 2 on Wednesdays and 3 on Thursdays and then like 7 on Fridays. That math doesn't work out. It's like, but it's like 5 straight hours of workshops on Fridays.
There's only one programming one a week.
I know that well, Greg would be the actual authority on this.
There's 2 a week.
And then, yeah, after git pull, you should see, it should start yelling at you about a commit, about a conflict. And it should stop allowing you to pull, or stop allowing you to push once it's told you that there's a merge conflict.
Things work that you do not have located. Is this the proper response?
Failed to push some refs.
You can push without pulling.
I'll try pulling again.
So you have to pull.
It just needs
Oh, this is what it tells you when you get on there.
But yeah, it does say merge.
No.
Yeah.
I thought you still had to pull. Oh wait.
So did you try pushing after you got the merge conflict?
Yep.
Oh,
Yeah, merge
one of you would push and pull, so you have to pull and push first.
And so, we'll
And then when I pull.
Right, just try pulling and see what happens.
So did you pull?
Wait,
Wait. Oh yeah, you.
So I think you'll still say merge conflict.
Yeah.
It just says exiting because of an episode conflict.
we are teaching rebase.
Yeah, I think you just you freaked
Oh,
out.
no. I think it just do get pull.
Yeah.
And then so get push.
Wait, how did it show my name? Oh wait.
What are you?
Okay, then I'll. But they always tell me to do this.
But I think I might have pulled after the already uploaded, so it just like changed.
Yeah, it always asks me to do that too. I
Oh,
just
that's
put
not
-m.
bad.
That time I put -m quotation message and then it
Okay, get push.
That's what I had.
And I got rejected.
it wants you to pull.
Oh, I didn't pull?
Try to pull first.
You have stuff to pull.
No? Oh, I guess. Oh, see, I'm.
Conflict, merge conflict. Okay.
There's a conflict now.
Oh, you have uncommitted. You haven't added. You haven't committed your changes.
What?
Did you do git add? Yeah.
Oh yeah, you're right. Let's do it, girl.
Yep. Now you have a conflict.
There we go.
All right. Does anyone not have an on fire git right now? Everyone's git's on fire?
Yes.
Yeah.
Cool. Let's put out some fires. Let's do actually useful stuff. So if you open up your conflicted file in a text editor, you should be able to find something that looks like this. So whatever file you lit on fire, go ahead and open it up, and you should be able to find a section somewhere in there that's going to look a lot like this. In the conflicted file, whatever file you both made changes to. It's only going to be on the person who has the commit, the conflict. Only one of you will have the conflict.
Got it.
Because Git is trying very, very hard to keep the fire under control, so it's only going to put it on one person's computer, and it's not going to let it spread.
Okay.
They shouldn't.
What is that one C looking for?
This is a commit ID number. This is the commit ID number of the other person's commit that's conflicting with your commit. Yeah.
Every time we pull, do we also need to write a message? Because it's not letting me pull without writing a message. Is that?
As long as you are actually pulling changes, you will need to be writing messages.
Okay.
Because every time you pull, you're merging.
I see.
and every time you merge, you need a merge message.
So every time we pull or commit, we're gonna need to put a message if it's gonna be.
There's gonna be a trick I'm gonna teach you that can get you out of pull messages later. It has some other downsides, which is why I'm not starting with it. But there's a way out of that. And then, so basically what you're gonna do is you're gonna see that this is your version up top, where it says head is the version of this line that you've made. And then whatever version someone else made that's causing the conflict is gonna be down here. Where's my laser? There it is. Weird. And so basically all you want to do is you want to just go ahead and delete all the stuff that you don't want to keep. Right? So you just need to choose which one of these versions you actually want, and then just delete all the other stuff that's here except for that one line you want to keep, right? So if I decided the quick brown fox jumped over the lazy dog is the correct version of this line, right? That's the version that we actually want. Then I'm going to delete head, I'm going to delete this should end well, I'm going to delete these equal signs, I'm going to delete this long garbage down here, and I'm just going to leave the quick brown fox jumped over the lazy dog. And then once you've done that, right, once you've changed that file so that it's the version that it's the way it's supposed to look, now you can just do an add commit pull push cycle to push your newly merged and unfired version up onto the remote. So go ahead and put out your fires.
Just leave cat in. Do it so you don't have any problems.
Is there a way to not open up bin? Because that happens about 50% of the time.
Yes, we're going to teach you a trick there. You can also program it so that it opens up as or you can actually change the configuration.
You switch it to yours and then upload it again.
Or you can learn tips, so you can actually be writing messages. But yes, there is a trick we'll teach you that will get you out of that. It introduces some other scary stuff, but gets you out of all the merges.
Oh, okay. Oh, so these are commit. Oh,
Yeah, I just want the game so special. And it's going to be my signature game. So,
He's ready to share.
you can start any more development.
after the
Oh, whenever it does that, you just type in capital Z, capital Z.
You can put even into the whole force stuff.
Oh, escape, capital Z, capital Z.
Oh, escape?
Yeah.
Did you open
Then capital Z, capital Z.
Does it say A or
Shift capitals. There you go.
Oh, got it.
and then
How do I?
Yep.
No. Turns on my signature, honestly.
Greetings, imperious citizens of this country.
Oh, okay.
Failed to push because you have an unresolved Git you haven't resolved your conflict.
No, I haven't.
Can you save this one?
Yeah.
And then have you added it and committed it and all that jazz?
Yeah, okay, I'll read it.
Yes. Fine.
And you got a message, right?
Yep.
Sorry, I got
Usually when after a merge conflict, your message is fixed merge conflict. You can try it.
Way longer and way more energy than that shit.
No.
Literally all I need. Now I need to
Yes.
Are there any restrictions on file size or type?
Git does not have any restrictions. GitHub does. GitHub will only accept files up to.
Yeah, it should do.
Does anyone know the maximum GitHub file size on
How
the
to deal with merge
It's like
conflicts.
500 megs.
Yeah, that sounds right.
One second.
What? Well, you can't. That's not on total. That's on a file by
Apparently it's
file
100
basis.
megabytes.
Oh. So as long as there's no files in there, that
You can have a giant collective piece of software that each individual file.
1 gigabyte for the.
Yeah, it's 100 megabytes.
100 megabytes for one file, 1 gigabyte for line.
for the repository.
Yeah, right. Gotcha. Yeah, so it's like total access. Gotcha.
the last time I tried to push a giant 8 gig file onto my GitHub,
Oh, that
it
might not let you do. But
it just like straight up did not let me do it.
But if you upload like 30 90-megabyte files, it might just, I think it just sends you an email saying, hey,
Oh.
Zero shame.
Don't waste our server space.
yeah.
Okay. Has everyone put out their Git fires? Okay. So we've kind of gone through the 2 most important things that you're ever going to do with Git. The add commit push pull cycle is, or the add commit pull push cycle is like 90% of everything you're going to be doing in Git. Merge conflicts in theory should be 0% of what you're doing. Realistically, they're going to be a lot more than that. So I'm just going to teach you some cool shenanigans you can do with Git, some fun little tricks to make your Git life nicer. So the first thing I'm going to teach you is a nice little tool called Git Stash. And what Git Stash basically does is you notice how Git won't let you pull by default unless you have committed all your changes, right? If you have any uncommitted changes, Git by default won't let you pull because it does not want to risk doing a merge with uncommitted changes running around, right? When it goes into a merge, it wants all its changes to be nicely tucked away into commits. So it won't let you pull unless you've committed all your changes. This is normally fine, but it can get annoying if, like, I'm halfway through writing a file, and then, hey, my friend finished a feature that I super need. I want to pull this feature, but hey, I don't want to commit half a file. That's a dumb commit to have laying around, right? Usually you want your commits to be nice, whole units. So what do? Right? I don't want to commit, but I have unadded changes, and I still want to pull. The answer is this beautiful little thing called Git Stash. Basically, the way Git Stash works is it works in 2 parts. Git Stash itself takes all your uncommitted changes, it remembers them, and then it undoes them, right? So they're all saved, but they're all taken out of your working directory. Your working directory is cleaned to the last commit that was put there. And then Git Stash pop takes all the uncommitted changes that you have saved, and it applies them to your working directory as if you had just made all those changes. Does that make sense to everyone? Right? It basically lets you, if you're only allowed to pull before you make any uncommitted changes, it just basically says, hey, all these uncommitted changes I just made, pretend they happened after this pull, even though you actually did them before you pulled, right? You just kind of get to move them on the timeline by saving them and then redoing them later. Any questions about how Stash and Stash pop works? Okay, so we're going to do a little exercise with this because of course we are. I'm your workshop giver. So I want everyone to pick a file somewhere on the GitHub and then just go start making some changes to it. I'm going to go make a new file that I'm going to push to all of you guys. No one commit any of your changes, and I want you all to be able to, midway, when I tell you to, midway through making all these changes that you're not about to commit, pull in the file that I'm going to push to you.
So we only get add dot.
What?
Do we get add dots to it?
Nope. You just go straight to Git Stash, and it'll take all your uncommitted changes, be they added or not, and stow them away. All right, any questions about what's about to happen? All right, get making weird changes. Oh, and this is the instructions for what we're doing, if that wasn't abundantly clear. I need to pull first. Let me pull. For those of you curious why stashing is so important, I just tried to pull with uncommitted changes. This is what the message looks like. I'm just gonna do git reset --hard. save this. Go back over to, where's my Git? Here's Git. Now git add dot. All right. And all right, and pull. Don't commit, just pull.
Okay. Please commit your changes or stash them before you merge.
Oh, yeah, that's supposed to do that. They're not supposed to
Git
exist.
stats.
Yeah. What's the other dangerous one? Just dash hard or something else I forgot about.
Rebase?
So we can do
No,
git
like
stash
one
and
that
then
reads
git stash
like
pop,
really
right?
You can lose your card dash on card.
Yeah, I was wondering if there was another one.
Git stash.
Soft. You don't think you use anything soft.
And then git pull. And then git stash pop.
Maybe it's best we don't know the old one's name.
I've been reminded to tell you guys that you noticed I kind of had to pull a command that I pulled this command, git reset dash dash hard. There's a reason that's not in this workshop. It's a very dangerous command. I've been using Git for years. I know what it does. I'm confident I won't explode things. But even then, I'm not that confident I won't explode things with git reset dash dash hard. Don't use git reset dash dash hard. Forget you ever saw it existed.
Wow.
Notice.
Okay,
But then you drew
cool.
a ton of attention to it.
Okay, well, he noticed it, and he was worried that one of you had seen it, so ignore everything.
I added in.
You notice the things I do.
Oh, really?
But yes, git dash dash hard is basically how you say, hey, all that work I've been doing for the last hour, to the wind.
Nice.
Yep. So you pulled with, you got the commit pulled? Maybe the git stash pop? Yeah.
So then, so we had to do git stash and then git pull and then git stash.
You don't have anything to push.
This is like
Didn't. I stashed it, pulled, re-thinged it, and I'm trying to push it to see if it actually like pushes the old thing or the new thing. But it did. It got rejected.
I pulled a stash today to push my thing.
Yes.
Okay.
So remember there's going to be a
so
set
you
thing
get
before you actually push it. No.
Or a stash.
And then, where are those changes right now? Are those changes on your directory?
Yeah.
No.
Because they're stashed away.
Yeah.
You need to stash pop to get them out of your stash pop. Which I think is actually your problem too. Did you remember to use stash pop?
Yep. I'll try it again.
And you
Is it git stash pop or just stuff?
Oh,
Is it made new files?
So, you pull, then you stash, and then stash pop.
Let's see.
You want to stash and then
Up
pull.
Oh.
Change it right to
This should still work.
That's fine.
Yeah.
That's
I stashed to save it.
Yeah.
Right, that's how it works.
But I
Don't. You're not
just
supposed to.
committed mine. Change.
Oh, you already pushed it.
Oh, maybe you should try. I should try Git.
Swap file.
I'm in 141, but it's like, I need to win this, so can you send that? Hold on, check.
Remember to always
Oh.
always remember when you get a dev prompt to use these
Yeah.
stuff, right?
It's annoying because it's
basically what it's telling, so this is a Vim thing, this is why Vim is weird. This is one of the many things that makes Vim weird and terrifying. Basically, if you close Vim improperly, which I happen to know just from the beginning that you did once, it leaves a swap file on your computer.
Okay.
And then whenever you open a file in Vim, then looks for that old swap file, it sees that old swap file, and it doesn't know what it's doing there, so it freaks the fuck out.
So how do I delete that little swap file?
You need to hunt it down. It can be pretty elusive. Because it deletes all its own swap files when you close Vim, but if you don't close it correctly, it won't get to delete that.
Just search my entire PC for swap files because there can't be that many. Does that get deleted eventually? Or
It gets deleted when you close Vim properly. If you don't close Vim properly, your window to have it deleted naturally goes away. My computer is just covered in old Vim swap files that I've never bothered to delete. Okay. Is anyone still having trouble with polling? With stash?
When I did git stash pop, it didn't work, and I had to actually add the file that I had stashed. Git add file.
It has been pointed out to me that if you do this, if you try to stash your new file that has never been worked on before, that file is in this kind of weird limbo called being untracked, and it won't stash untracked files.
Oh.
So you have to actually do something to the file with Git, such as git add, and then stash it, so it goes from untracked to tracked.
Yeah.
And then it will work correctly.
So essentially what you're saying is I not forgot to git add, but I do git add before I
Yes.
stash it.
You don't normally need to do that.
Oh.
You only need to do, because if Git has ever done anything to this file, if this file has ever been committed before or changed by a commit before, it's still tracked. Git will stash it.
Okay.
If it has never been touched by Git before, it's still going to be in the untracked state,
Got it.
and it won't It won't stash untracked files.
Interesting. Okay.
Because as far as untracked files are concerned, they're out of its domain. It doesn't need to worry about them. It's not going to change it. So it's not worried about getting collisions because, it's not going to change it. So why would it change it does to it? Because it's not going to do any changes.
Yeah, that makes sense. There's nothing to change.
Yeah. So you need to do something to make it tracked. And the easy way to do that is by adding it.
where would that file be, and what would it be called?
The swap file?
Yeah.
It would be deep inside of your .git directory, and it would be called something.swp. It'd also be a hidden file. Swap files are always hidden.
Aha! Got it.
Okay. Shall we move on? Yell and scream if you're not ready to move on.
This is what
Okay.
files pop up.
We did that challenge. Okay. So now we're going to talk about the most important thing, not actually, but a pretty powerful big tool in Git. That's also kind of one of the scarier tools. Branches. So we've talked about branches a couple times before, right? The idea that I don't have to have all, right? Like, I can have multiple copies of the same repository with different sets of commits, right? And we call each of these a branch. A repository can have any number of branches. By default, it has one called master. Right, that's the branch that we've been working with, is the master branch. But you can make more. And then if you've made 2 branches and you decide you want a new branch, or you can't actually do, and once you've made some branches, you can decide that you want a branch to have all the commits that another branch has. And that's called merging. where basically you take all the commits on some other branch and you pull them onto your current branch. Right, you can change which current branch your current, yeah. Okay, any questions about the basic setup of what a branch is? Or what we do with them? There are a few basic setups or types of branches you're going to have. The really simple one that a lot of people use that's very good is master and dev. Basically, you have a dev branch, which is where all of your changes are made. You're always working in dev, and then every time your program or game gets to a stable, complete, like I could publish this state, then you pull it over, or then you merge it onto master. Right, and then you go back to working on dev and making changes and building bugs, and then every time it gets, polished and nice, then you pull it onto master. Some companies use a more advanced version of this system that has like 3 or 4 layers of branches going on, right? And then as it tests and reaches higher levels of quality, gets pulled down or gets merged down the various branches until it gets merged onto master. Another classic setup is whenever you're making a new feature, you give that feature a branch, right? And then you just wait until that feature is finished, and then you merge that branch onto to master. It's a very similar setup, but this one allows you to actually, I can build the networking for my game without having to worry about interference from local multiplayer, which is also being built in some other branch over there, right? Or some new game bugs, or some new gameplay features, right? I don't need to worry about that while I'm working on adding networking. And then there are a whole bunch of other setups that you can do with branches. A whole bunch of useful setups. And then there's just a little note at the bottom that points out that, yes, this is the same merge as merge conflict. Technically speaking, what a pull is actually a merge between 2 parallel branches on different computers, right, on different associated repositories. So merges can have merge conflicts because pulls are just fancy merges. If you were wondering about that lingo. Any questions, comments, concerns, clarifications, misgivings about what a branch is or why you want one? Okay. So here are the 3 basic Git commands related to branching. If you want to make a new branch, you just do git checkout b, git checkout -b, and then the name of your branch. You can give it whatever name you want. It will make a new branch that is currently identical to whatever branch you were previously on, and it will take you onto this new branch, right? So you're branching off of whatever branch you're currently on. If you want to change which branch you're working with, right, you can do git checkout no-b and then the name of a branch, and that will change your working directory to match whatever branch you just said, right? So it'll delete all the files not in that branch and all the commits not in that branch, and it'll apply in all the commits that are in that branch that weren't in your previous branch to your working directory, bring in all the files only in that branch. And whenever you do commits and stuff, you'll be committing only onto that one branch. Whenever you do a commit at all, it only commits onto your current branch. And then you need to merge it onto other branches. And then if you want to actually merge, you can do merge branch. And what merge branch does is it takes all the commits on some other branch that you just named that you don't have on your current branch and pulls them onto the current branch. Pull is a wrong word. Applies them onto the current branch. Merge them onto the current branch. It doesn't change the branch you merged from at all. Though usually speaking, that branch is kind of considered dead at that point, and just a part of your current branch you just merged onto. Any questions, comments, concerns, clarifications, misgivings about any of these 3 basic merge commands, or branch commands? What they do, how branches work? Okay, so we're going to do a very basic branching challenge to start. I want everyone to, first things first, you're going to need to make a new branch. And then make some changes in that branch, right? Add some files while you're in that branch, commit them, and push them. And so we'll start there. So everyone go make a new branch with git checkout-b branch, do some stuff to that branch, and push it.
Just name the branch.
Yeah, name the branch anything. Just, you know, the standing warning with Git is everything you do on Git is open to the public to see. So, or I guess anything you do on GitHub, technically. If you had a private Git server, then they would be able to find that.
So what do you do after you make a new branch?
Once you're on that new branch, go ahead and make some changes to it.
Okay.
Add some files, change some files, whatever. And then go do an add, commit, pull flush cycle.
It's like
So you're on a branch. Yep.
and then preference. Just change anything here.
Mm-hmm.
Why does it only show these two?
I don't know that. I don't know why it's saying those. That's weird. Okay, it should be fine.
All right.
No, but that means you need to
I create a new branch. What do I do with it on that?
The thing is,
Do the push pull loop thing?
you're rotating your file 90 degrees. So what that means is basically
What do you mean you're rotating it 90 degrees?
on 45 degrees.
Oh, okay.
Git is what it is. That's what, oh, wait.
So it actually works the same way as
So we're just moving the camera.
What would you put it in quotes or anything?
You know, I wasn't going to
What
think
would my
of
branch
that,
be called?
but that would be the smart way to do
Maybe.
this.
Is that what it is?
So yes,
Yeah, it looks like it worked.
do that, and not what I was about to tell you.
So wait, what do we do after we
Basically, the way you normally do asymmetric is, so normally the way you convert, when I talk about grid space versus screen space, you know the difference?
I have my new branch. I don't know what to do with it.
Yeah, I mean, they're working.
I need a
Give you like 30 seconds. So you know the difference between world space and screen space?
God.
So like you have coordinates on your screen, and then you also have a separate set of coordinates in your actual control. Yeah.
Versus like.
Yeah. So normally all you do is you apply an offset and you apply a coefficient to convert between them. Which is really easy, right? Like offset is how far you
Yeah.
scale of data to. You convert it from screen space to grid space.
Okay.
The thing that makes isometric weird is because it's rotated, your conversion between grid space and screen space actually needs to undergo that same rotation, which is basically just a weird multiplied by a bunch of square roots. Yes.
Now that I'm on branch, I make changes and I add them and I do them just
Okay. You don't technically need to pull because you know for a fact that there aren't going to be any commits to pull.
Yeah.
It's just a good habit to
pull
begin.
in this. It's not giving me any errors.
Exactly. Right? It'll just tell you, hey, there's nothing to pull.
There's no tracking information.
Or that.
Next question.
Yeah. And then go ahead and push.
Push table. And then it should have no upstream branch. Oh. Oh, did I skip this? Oh, I
Did
skipped
you
it.
remember to do git checkout-b?
Yeah.
Oh, or okay, just do that.
Does that mean I'm merging the same?
No, it's you're telling it. So when you're pushing and pulling, you're going to a corresponding branch on your on the remote. That corresponding branch is called the upstream,
Oh.
and you need to tell it manually which branch goes to which other branch.
Oh.
So that's what set upstream does. Is you're telling it basically what you're saying is set upstream is I'm telling you what upstream I want this branch to sync with. Origin is telling you which remote that upstream is going to be on. Origin is the default name for any remote, and then the last name is the name of the branch on that.
Wait, so I have my branch. How do I make it? How do I set the master?
This command right here.
Where does the word master go?
Oh, we just mixed it.
What do you mean, like master?
So like upstream, where does anything go? Do I just type that in word for word?
Yes. So master is the name of the other branch.
Yeah.
You don't want your branch to be playing with master, right?
No.
You don't want. You're not dealing with anything with master. Basically, so you know how every branch on your local repository corresponds to a branch on the remote, and that's where pull pushes and pulls from.
Yeah.
Basically, that branch over there is called upstream. You need to manually tell it which branch on your repository corresponds to which branch on the remote repository. So that's what set upstream does. Is set upstream says, hey, I'm going to tell you what upstream you're going to be pushing and pulling from. Origin is telling you which remote, because you can't actually have multiple remotes. Origin is the default name for any remote, and then the name of the branch.
So now it should be able to.
You might need to refresh the page.
There we go.
Yep. Anyone else having trouble making a new branch?
So what do I do after I make a branch?
So you've made some changes to it?
Yeah, I made.
Have you committed those changes?
Oh, no, I guess.
Yeah, so go commit and pull those changes.
Go add to, like yeah.
So yeah, the whole cycle. You always do the whole cycle. It's a monotonous thing. So once you've done that, the next thing I want you guys to do is I want you guys to go git checkout master and flip back over to the master branch. And then I want you to see if you can find your changes on the master branch. So git checkout master.
Just take this in here.
Yes, yes you do. Do you want me to explain what that?
Yeah.
Wait, that's, huh? No, bad. Don't do that one. You made a new branch. Yes. You committed. Git push.
What is the master branch called? Origin or upstream?
Neither. Upstream is the term for any corresponding branch. Origin is the name of the remote. Okay. The master branch is called master. Okay. This is the command. Yes. Basically, so upstream is, you know how we are dealing with corresponding branches? Yes. The corresponding branch on the remote is called the upstream. When we make a new branch, we have to set which branch corresponds to which branch manually. So that's why we need to set the upstream, right? Tell it which branch is the upstream for this new branch. Origin is the name of the remote that upstream is on, right? Origin is the default name for any remote. And then after that is just the name of the branch on origin. Everything good?
Check out the master branch are you talking about? Up here? Or
Your folder. So you've checked out master? Git check out master. And then just look through here and see if you can find the changes you just made for your branch to prove to yourself that branching does in fact work.
It does.
Cool. And then when you've done that, the next thing after you've swapped back onto master and seen that in fact your changes aren't there is to make your changes be there. Go ahead and merge your branch onto master.
I deleted a lot of files.
The fun thing about Training Dummy is that no one cares. I literally made this repository for you guys to mess around with and blow up each other's stuff.
What was the command to merge again?
Merge. It's git merge and then the branch you want to merge from.
Merge from or merge with?
If this
so do I
is,
type in master or the name of my branch?
type in name of your branch, right? If we are here, if this is where head is, and this is named B, the command that does this is git merge b. And then of course git merge b will move head over here. Wait, I wrote A. Alright, so you want to write the name. From master, you want to write the name of your branch to pull the changes from your branch onto master. And if, for example, someone merged some new fancy features onto master that you want in your branch, but your branch isn't done, in your branch you would say git merge master, pull those new changes that someone else put onto master onto your thing. Does that make sense? Yeah, what's up?
So I push, and then this is the upstream thing. Do I like type this in?
Yes.
Yeah.
Did you overhear my explanation of what that does, or? Okay. So you know how we have corresponding branches on different? Yeah. So the corresponding branch on the remote to your personal branch or to your local branch is called the upstream. We need to tell it which branch goes to which other branch manually. We need to set those branches manually. That's why you need to type in that command.
Okay.
Basically, you're just saying, and then origin is the name of the remote, but it's just the default name for any remote is origin. And anything is the name of the branch on remote that you are setting as the upstream for your local branch named anyway.
Okay.
Make sense?
Yeah.
Awesome.
Oh wait. This is no remote recurrent branch.
Did you set oh, you need to say git merge and then the name of the branch
Oh.
you want to merge from. Did you remember to make commit changes to anything?
No. Oh, it's pushing.
Yeah.
And there were in fact changes there. To cause change to insertions and deletions, yeah. Scroll all the way down.
Yeah, it showed up. Oh, shit.
Oh, you're still on any change. You haven't changed over to master.
Oh.
So if you try to tell anything to get all the changes that are on anything that anything doesn't have, by definition doesn't. Yeah, so you need to move over onto master to merge changes from anything onto master.
Okay.
And then you do that with git checkout branch.
Yeah,
Yes.
mine doesn't want to merge automatically.
What do you mean?
It's only to do a pull request.
Oh, don't do this on GitHub. Do this on your machine.
Well, because I did it over here, and that's what it told me to do, because then this came.
Git so you're moved over to master, git moves onto master. It looks fine.
Yeah.
And I just do a git, just do an add commit push pull cycle.
Oh, okay.
Or actually no, you don't even need to do an add commit push pull. You just need to do an pull push. Pull push should be enough. Yeah.
Any questions? For today?
We have one last little shenanigan. Trick. Okay. So for those, while you guys are still finishing that up, we all need to get to class in like 10 minutes, so I'm gonna kind of run through this last little thing that we're gonna teach you, which is a trick called pull rebase. I promised you that I would tell you how to not have to use Vim at every single pull. This is how, pull rebase. This is basically explaining how git pull is a merge of two git commands, git fetch and git merge, right? Basically, this is what I mean when I say pull is a fancy merge. And so the reason you're constantly needing to go into Vim is because, as I've said before, every merge requires a message, right? And so you're doing a merge when you pull, you need to make a merge message. Git pull rebase, however, actually allows you to get around that. And the way it gets around that is basically, so this right up here is what a normal merge looks like, right? Here's the remote branch that makes some changes. Here's your branch, local branch, that makes some changes. You pull those changes, you've now done a merge, right, of these two branches. Git pull rebase basically makes it look like those changes were on your local branch the whole time. right? It doesn't merge them on, it just kind of slides them onto your branch stealthily. It also kind of works a lot like stash pop, where it puts on the remote changes and then your local changes on top of that. It's very handy. It keeps things looking pretty, right? It keeps all kinds of crazy and necessary merges out of your commit history. The person who wrote the slide is very biased. They use Git pull rebase a lot. I do not. So, right, it keeps things very pretty. It prevents you from constantly having to deal with Vim. The problem is, as they put here, it's rewriting history, right? It's lying about where commits came from or what order commits were made in. Because commits were not made in a linear order. Your commits and the commits you pulled were made asynchronously, and then they're being merged together. This is making it look like all these commits happened and then all your commits happened, which is just factually false. Right? You don't want to play with other people's commit history. You're only not really playing with other people's commit history. You're playing with your local commit history on your repo, not their repo. The big thing where this kind of becomes a problem is sometimes you want merge conflicts because you want to know when your changes are fighting each other and you're about to lose code because someone overwrote someone else's code. Merge conflicts are nice that way. This will just rewrite someone else's code because it looks like the changes are linear, ergo the latter change obviously gets precedence. Which can be bad. This can delete all code without you ever being told, hey, I just deleted a giant pile of code. But, you know, if your doing practice is good and no one's working in the same file, you're not going to have merge conflicts anyway, so you don't need to worry about it. So it's very clean, kind of playing with fire, but, you know, if you're smart about things and you're doing good Git practices, you don't really need to worry about it that much. That's a fun trick that you can do, Git pull rebase. And I don't think we have time for this. It's not very hard. If you want me to teach you how to set up a repo with Unity, I will. But for now, I think we need to get to class, and you can probably figure this out on your own. What?
I can run through this super quick.
Or Greg can run through this. Yeah. Awesome. Okay, thank you, Greg. I have to head out. I gotta head out.
Okay, so with all of that out of the way, Git the Beast has been conquered, and now we're going to set up a quick GitHub repository. So you want to go on, yeah?
I was going to point out one thing to you guys. Now that you guys are on, whatchamacallit? Now you guys are on test training dummy, or training dummy, as my typo was lovingly dubbed. That is just a repo that I set up for like people to practice Git on. So if you want to try some Git tracks or practice doing branching patterns and merging weird stuff, or want to like have a safe space to try something you need to do in Git before you do it on a repo that you actually can lose stuff, feel free to just blow training dummy sky high and have fun with it. It's for you guys to play with. Other than that, thank you. I need to go to lecture. Thank you, Greg. Pay attention to him.
No problem. Okay, so with that out of the way, we're going to go ahead and set up a GitHub repository. So you want to head on over to the GitHub website, and I believe in the top right-hand corner, you can set up a new repository. It'll take you to this page here where you can give it a name, a description if you want. You can set it to be public or private. I believe if you are a student, you get to get private repositories for free, provided your account is linked to your UCI email. And basically take a look at that stuff. Any questions about setting up a GitHub repository? Are there any problems? Are y'all able to navigate to this page or something that looks like this? Because if so, we can move on. So, configuring your Unity project. Once that's set up, you're going to get a page just like the one for the Training Doomy page. You're going to clone it the same way you did with Training Doomy. And then what you can do is you can make a new Unity project inside the folder
for your repository. It's just basically the same process. You take that little .git thing, you copy it to clipboard, you do git clone inside the repository, and then you can set up a new Unity project inside of that folder. .gitignore. This is a neat little file. So there are many types of objects, including Unity projects, that have files that you don't want to share between team members, such as settings files. Unity has a lot of those. Unity also has a lot of temp files, cache files, just you name it. You don't want that on the repository because the rest of your team just does not care about it, and it's a waste of space. The gitignore is a file in your working directory called .gitignore, and it lists files, file types, and folders that you don't want to track and share in the repo. Really quickly, on the make repository page, there is a add.gitignore button. There is a preset GitHub has for Unity, so it'll automatically selectively take out, it'll put a gitignore inside your repository automatically that basically pushes all those Unity cache and temp files out of the way for you. Remember to add in a Unity gitignore before your first commit with Unity files, retroactively ignoring something that is actually annoying. GitHub provides a template, it provides a template.gitignore ready for Unity. Your challenge, if you haven't already created a new GitHub, transfer any files you have already made to it or make a new project. You can do this if you want, if you guys want to go ahead and make a new Unity project inside the folder. It's pretty simple. Basically, you make a new Unity project with the same name as the folder, I believe, and it should automatically place it in there. But we can go right ahead, and I'll answer questions after this about setting that stuff up. Last but not least. Oh, okay, so some rules of thumb to save your Git life. So, always pull when you sit down to work and push at every version that runs correctly. So when you do that, basically at the beginning of your day, you're going to sit down, you're going to pull, and you're going to see what everyone else has done from the last time you got up and got away from your computer and went to bed and did whatever. Never having two people with unpushed changes in the same file at the same time, communicating about who is working where. So this thing about merging and Unity is quite annoying. There are files that look like code, or they're lines of code, and you can merge them, and that's that. That's the whole thing. That's that. There are other files that are called binary files. They're things like compiled executables, or I think some Unity files where you cannot merge them because they are essentially just long, never-ending strings of bytes that you cannot effectively merge together. So having communication with who is doing what and where. Oh, Unity scene files. Unity scene files are essentially, they're not binary, but they are very, very, very long. They keep track of what objects are in what scenes. They are a huge mess. Imagine putting a game object in one scene, pushing it, and then two people move the game object to different places, and then they change the materials and add components, and then people try to merge the scene back together. You won't know what you're looking at with that merge conflict because there's going to be a couple hundred lines you're going to try and merge back together. It's a pain. I recommend for working in teams to essentially split up everyone's work into different scene files or use branching, as Ryan stated before. And effectively, just basically that last line there, communicating about who's working where is very, very important. And consider keeping the development of different features in different branches. As Ryan pointed out before, you can have your AI guy working in AI branch or AI scene, whichever you want to do. And essentially, they work there. You can work in your FPS controller scene where you essentially get your first-person shooter controller working. And then you don't need to merge scenes together. You just kind of prefab everything, and you can bring it together in scenes later on. Or your branches can come back together, and everyone has their own little files. And it's nice and happy. You're not going to need to touch Vim. You're not going to need to resolve merge conflicts. And at the end of the day, everyone goes away without screaming and crying because Git fires are fun. And yeah, that looks like that's it. So any questions about using Git with Unity, working with teams, setting up your repository, anything like that? All right then, cool. Workshop is done. So by now you all should know the bare basics of Git, some bare basic Vim to get you through the day. There's a friend out there. And you can get started with working with teams on projects. Where's the front of it? Hold on. Really quickly though. I would like to point out, yeah, okay, so Git Clients. I'd like to stress that using a Git client is very nice. Don't use GitHub Desktop. It is a dumpster fire made for probably high schoolers and nothing more. It just gives you the bare basics and you can't really do much else with it. I personally do use Tortoise Git because it implements itself into Windows itself. So you can right click on your repository folder and you get access to commits. You can see logs about who committed when and where. You can do merge conflicts using an interactive tool. So you can go through a file and say, I want this text block, I want this text block, and then come back together. You can pull and push with just basically one button press, and basically it's great. I haven't used SourceTree before, personally, but I do hear that it is very effective and a lot of important people do use it. If you find anything else that you like, Itai, what do you use? Do you use Git Kraken?
I switch between Git Kraken, Git command line, and SourceTree.
Yeah.
So I've used like every other one.
Basically, there are a lot of Git clients out there for you to use. So pick your favorite, stick with it, learn it, because you are better than your tools. Your tools will only take you so far, and mastering your tools will get you into some very great places. And Git is one of them. Git is a great tool. It really beats working out of Google Drives. And that is that. No problem. And we streamed this, so